What did ancient animals sound like? We have never truly heard the prehistoric world. No sound of huge dinosaurs, no sounds of ancient seas, no voices of the first land creatures. But based on the structure of the skulls, respiratory tract, and comparison with modern animals, one can imagine what he was like. And the ancient world most likely sounded completely different from the films. Large dinosaurs probably didn't roar like lions. Their anatomy suggests otherwise. Many did not have such vocal cords, and there were complex air cavities inside the bones. It's more like a resonator system than a roar throat. Their sounds were probably low, dull, and vibrating. Not a sharp scream, but a heavy rumble that is felt by the body. Such low frequencies travel far and bend around obstacles. The forest might seem quiet, but sound waves were constantly passing through it. Signals to the flock, warnings, mating calls. Animals could talk at a distance without seeing each other. The strange bony ridges of some herbivores were also likely part of the sound system. The air passed through the channels, amplified, and created a characteristic timbre. Each type could sound different, as if it had its own instrument. The seas of antiquity were not silent either. Water conducts sound well, so any click, body impact, or movement travels far. Sea predators could navigate vibrations, sense prey, and hear schools from a distance. The ocean was filled with the background noise of life. Even ancient animals probably had sounds associated with caring for their offspring. These were short signals, a squeak, a call. They weren't complex songs, but they had meaning. Find, warn, and keep close. Sound became especially important at night. When the light disappeared, hearing became the main guide. Any rustle could mean the approach of a predator, and any movement could mean a chance to survive. The darkness was not empty. It was filled with the sounds of footsteps, breathing, dull blows, and sudden screams. We will never know for sure. Sound is not stored in stone. It is possible to reconstruct the shape of the skull, the respiratory tract, and approximate frequencies, but it is impossible to restore the timbre and character of the voice. What exactly this world was like to hear will forever remain a guess. But if you imagine him as a whole, he was not quiet. It was filled with the roar of giants, the clicks of predators, the sound of water, and constant signals of life. Not music or chaos, rather a huge living system where every sound meant something. Danger, searching, hunger, or the presence of other creatures nearby. A color we'll never see. Coloring of extinct creatures. When we look at dinosaurs or ancient sea animals in books and films, we see green, gray, and brown colors. But the truth is that most of these shades have never been seen, and he won't see it again. Almost no color is preserved in fossils. The skin decomposes, the pigments disappear, leaving only bones and prints. Therefore, for a long time it was believed that it was impossible to restore the color of ancient animals. But then it turned out that something still remains. In rare cases, microscopic structures, melanosomes, are preserved. These are capsules and cells that are responsible for color. By their shape, you can understand whether the area was dark, red, striped, or iridescent. This is how scientists began to reconstruct the real colors of some feathered dinosaurs for the first time. And then it became clear, the ancient world was not gray. Black and white patterns, red shades, contrasting stripes, and perhaps even iridescence appeared, like in modern birds. Some dinosaurs probably looked brighter than many modern animals. The color was not needed for beauty. He solved problems of survival. Disguise. Herbivores could blend in with the vegetation and become invisible against the background of the ground and shadow. Signals. Bright spots could show strength, health, and readiness to mate. Warning. Contrasting colors are a sign that means don't touch. The cubs may have looked different from the adults, like many animals now. But even with melanosomes, we don't know everything. We don't know the exact hue and saturation, how the color changed in the sun, and what the animal looked like in motion. But color is not just a pigment. This is the reflection of light, skin texture, humidity, the condition of the fur feathers. Imagine a creature with feathers that shimmer in the sun, or a marine reptile with skin that changes color in the water, or a giant predator with a pattern that makes it invisible in the shadows. We can get closer to this image, but to see for sure is no longer possible. There are colors that have existed for millions of years. Bright, strange, unusual, and they disappeared, leaving neither photographs nor memories, just guesses. And the feeling that the prehistoric world was much more rich than the one we picture in our imagination. Smarter than we think. Sociality of dinosaurs and marine reptiles. For a long time, dinosaurs and ancient marine reptiles were represented as primitive creatures living solely on instinct. Hunting, sleeping, breeding. However, discoveries of recent decades are gradually changing this idea. Increasing evidence indicates that many of them lived in complex social groups, interacted with each other, and may have exhibited forms of behavior reminiscent of the collective life of modern animals. One of the key signs of social organization was massive accumulations of bones. Paleontologists find places where they died, dozens of individuals of the same species at once. This suggests that the animals moved together, forming herds. In such groups, it was easier to defend against predators, find food, and navigate in space. It is assumed that the juveniles stayed close to the center, and the adults formed a protective contour, as is the case in many animals today. Even more convincing evidence is provided by nesting colonies. In some areas, dozens of nests located nearby have been found, indicating collective breeding. The animals probably returned to the same places, and the cubs remained under the protection of the adults for some time. This pattern of behavior requires memory, recognition of their relatives, and coordination of actions. This is no longer just solitary survival. Judging by a number of finds, predatory dinosaurs could act together. Tracks of several individuals moving in the same direction, as well as the remains of prey with bites of different sizes, hint at group hunting. Such behavior is impossible without exchanging signals and understanding the actions of other group members. This suggests the presence of complex behavioral strategies rather than chaotic attacks. Social forms of life also existed in the oceans. Marine reptiles such as ichthyosaurs and plesiosaurs likely moved in groups and may have migrated together. There is evidence that some species gave birth to live young and stayed in certain areas where conditions were most favorable. Juveniles apparently stayed close to each other, forming temporary nursery groups. Life in a community is impossible without communication. It could occur through sounds, body movements, demonstration of ridges and fins. Some dinosaurs had complex cavities in their skulls that could amplify sound signals. Coloring could also play a role, helping to recognize friends, attracting partners, or scaring off rivals. It is important to understand that sociality is not necessarily associated with a large brain in the human sense. For her, the ability to recognize relatives, remember routes, respond to signals, and learn through observation is enough. Even modern reptiles exhibit much more complex behavior than previously thought, and their ancient relatives existed in rich and diverse ecosystems for millions of years, inevitably facilitating the development of collective strategies. When we begin to perceive dinosaurs not as solitary giants, but as creatures that lived in communities, the world of the Mesozoic changes. It ceases to be a silent arena of struggle and becomes a dynamic environment filled with interactions, signals, and relationships. It was a world where not only the strongest survived, but also those who knew how to act within themselves stay. Games of ancient animals, traces of non-survival behavior. When we talk about prehistoric animals, almost everything comes down to fighting. Hunting, protection, hunger, reproduction. But life, even in the Mesozoic, could not consist only of survival. Traces in rocks and skeletal finds show. Many ancient beings acted as if they were playing. And this is one of the most unexpected behavioral traces of the past. Gaming behavior is difficult to prove directly. It leaves no dice, but indirect signs remain. For example, chains of tracks where young individuals ran in circles, intersected, and returned back, as if chasing each other without a goal. Such sites are found near dinosaur nesting sites, including species like Maiasaura and other gregarious herbivores. Predators also left strange marks. In some places, chases are recorded, where one young theropod chased another, but without an attempt to attack. The tracks do not accelerate. There is no jump. There is no final contact. This is reminiscent of the training runs that can be seen today in young wolves or lion cubs. This behavior was likely found in small carnivorous dinosaurs like Velociraptor. There are also more unusual finds. Damage to bones without signs of struggle or hunting. Fractures healed in juveniles that are not associated with an attack. Paleontologists speculate these could be falls during games, pushing, jumping, running over difficult terrain. Marine reptiles have similar signs. In places where groups of individuals of the same age are found, for example, in Ichthyosaurus, there are no signs of mass death from predators or disasters, but there are signs of a long stay together. Perhaps the young stayed in adolescent groups, like dolphins today, learning to move, dive, and hunt through repetition and interaction. Games are not important in themselves. This is a brain and body workout. The game works on coordination, reaction to movement, social cues, and boundaries of aggression. The animal learns not only to attack, but also to stop. Understand when a partner is not prey. Even ancient herbivores have hints of similar behavior. The tracks of juveniles around adults sometimes form chaotic patterns. Loops, zigzags, sudden turns. This is not migration or flight. This movement without a goal is a characteristic sign of gaming activity. Sometimes the game could be associated with a demonstration. Young males bumped horns or jostled their bodies without attempting to cause serious harm. It is assumed that this happened in ceratopsians like Triceratops, training for future battles for territory and partners. The most interesting thing is that the game appears only where there is a safety margin. A well-fed animal, a protected group, a territory without constant threat. This means that Mesozoic ecosystems were not only violent, but also stable. There was a place for time wasted in them. This means that the ancient world was more alive than it seems. Not just hunting, not just fear. sometimes running for no reason, pushing, chasing, which end in nothing. It is precisely moments like these that make animals not just survival machines, but creatures with behavior that already contains the rudiments of what we call life. Hunting without teeth and claws. Strange ways of getting food. Filtration, suction, traps, water pressure. When we think about hunting in the prehistoric world, fangs, bites, and tearing apart prey immediately appear in our imagination. But a huge number of ancient animals survived completely differently. Without sharp teeth, without powerful paws, sometimes without direct contact with the victim at all. They hunted using water, pressure, flow speed, and even patience. Filtration was one of the most ancient strategies. Some sea creatures simply passed huge volumes of water through themselves, extracting all living things, plankton, larvae, small crustaceans. This did not require force, but a huge surface for straining and constant movement. Such forms could feed almost continuously, without wasting energy on the chase. Suction is an even stranger method. There were predators in the oceans that did not bite their prey, but created a sharp vacuum in the water and literally pulled the prey inside. The rapid opening of the mouth created a stream from which small animals could not escape. It was lightning fast and almost silent. Some species used water pressure as a weapon. They abruptly closed the body or fins, creating a wave that knocked the prey off course. In muddy water, this was especially effective. The victim lost orientation and became an easy target. There were real traps too, not mechanical like modern spiders, but behavioral. The animal froze, camouflaged itself, and became part of the relief. It didn't pursue, it waited, sometimes for hours. When the prey got too close, there was one short movement. Not a blow, but a grab by a flow or a sharp retraction. There were forms that fed on soft organisms, literally scraping them from the surface. They did not tear, but collected, slowly, systematically, as if they were cultivating the territory. In the ancient seas, there were also giants who did not need to be hunted in the usual sense. Their strategy is to move through clusters of life. They didn't choose the target. Everything that was in the way ended up as food. This method required a huge body and a stable ecosystem rich in small organisms. Sometimes, the hunt took place without contact at all. It was enough to raise a cloud of sediment from the bottom. Small animals hidden in the ground lost cover, surfaced, and fell into the flow of water, which he threw them straight into his mouth. Even on land, similar strategies were encountered. Some ancient animals used not their teeth, but the force of a body blow or a sudden movement of their head to stun their prey. Others ate by collecting insects, grubs, and soft life forms. Such a hunt did not require aggression, but accuracy, not strength, but calculation, not speed, but understanding of the environment. It is these forms of behavior that show how diverse the prehistoric world was. In it, not only those who could tear apart their prey survived, but also those who knew how to control water, flow, distance, and moment. Sometimes the most dangerous predator was not the one who bites, but the one who cannot be seen until it is too late. Names and habits of ancient animals that did not eat but absorbed food. Here are real examples of ancient animals that did not bite their prey, but sucked it in with a stream of water. Hunter vacuum cleaners of their time. Their strategy: a sharp opening of the mouth, creating a vacuum and instantly sucking in water along with the victim. Dunkleosteus. Giant armored fish of the Devonian period. She did not have the usual teeth, Instead of them, there were sharp bone plates. She could suddenly open her mouth, creating a powerful suction stream. Small fish and invertebrates were literally pulled in before they could react. Placoderms are armored fish. Many members of this group hunted this way. Their jaws were designed to quickly open forward, increasing the volume of the oral cavity. Water and prey were drawn in, and then the mouth slammed shut. Ichthyosaur. Early ichthyosaurs, especially small forms, may have used suction to hunt soft-bodied animals and small fish. The rapid opening of the long mouth created a stream of water that sucked in the prey. Plesiosaur? Some types. Long-necked marine reptiles probably used a combination strategy. They sneaked up and sharply drew in the water with their prey. This is especially effective in turbid waters and when hunting schooling fish. Ammonites, not active hunters in the usual sense, but many of them sucked in food through their mouthparts, creating a stream of water. They caught small crustaceans and organic matter using soft tentacles and retraction. Belemnites, ancient relatives of squids. They probably sucked in prey due to the rapid movement of the tentacles and a jet stream of water, after which they directed it to the oral apparatus. Early bony fishes. Many forms had a retractable jaw. She literally shot forward, creating a vacuum effect. This made it possible to catch prey without being bitten. The victim was drawn in along with the water. The habits of such animals were as follows. They didn't pursue for long. We got as close as possible. The attack took a split second. The main thing is not the bite force, but the speed of opening of the past sand. They often hunted in murky waters, where the prey was less able to see the danger. Some froze before throwing, others slowly swam up from below. Suction hunting is especially effective against small fish, larvae, soft-bodied creatures, and schooling organisms. This strategy appeared very early and turned out to be so successful that it is still used today in modern fish, whales, and squids. That is, hundreds of millions of years ago, evolution had already invented predators that did not need fangs or tearing apart their prey. One precise movement was enough, and the water itself brought food. Did you like the video? Give it a thumbs up and leave a comment. Subscribe and hit the bell so you don't miss new and interesting videos from the channel Real Unreal.